state-dependent memory. It's best to study in the same mental and physical environment you'll be in during the test, or to study in various possible states to make the memories independent from any particular one. Spend at least 1/4 of your study time simulating the state you will likely be in during your exam. For example, sit at a desk, time your answers. Study regardless of your mental/physical state, in different moods, with different energy levels, etc. Similarly, try to learn the information in the same way you'll be assessed on it, aka transfer appropriate processing, an example of which is doing multiple choice if the test will also have a lot of multiple choice. It also makes sense to put on facial expressions related to the emotional content of what you're learning. We smile to recall happiness, grimace to recall pain, and frown to recall anger. Theories of embodied emotion state that in order to process an emotion, we first reproduce the facial movements of the expression induced by that emotion, explains researcher Jenny Baumeister. Dunning-Kruger effect, seeking feedback and watching tutorials to build foundational knowledge. Also, remember the importance of taking on projects you care about without the use of guides. Consider pre-studying and over-learning. Novelty effect and isolation effect. Depending on the situation, recall may be better with novelty, familiarity, or association. For novelty, learn something that provides a new perspective or way of interpreting the material. Additionally, try to make information stand out, which can be done through interleaving. This can be done through the processing difficulty effect, in which information that is more difficult to process or absorb is often better remembered later on, as long as the complexity doesn't exceed your skill set. But an easy way to make use of this is to use unusual fonts. Another option is the humor effect, which is based on the idea that amusement or laughter creates a more enjoyable learning experience, leading to improved retention. Of course, this can backfire if you don't use humor appropriately and end up distracting yourself. Personal preference plays a role too. The self-reference effect, because we have a tendency to better remember information we deem personally relevant or related to ourselves, connect new information to previous experiences. Primacy effect and recency effect. It's easier to remember what was presented to us first and last. Spaced repetition / forgetting curve and production effect. Read important parts aloud. Spacing effect. Randomly pause every so often for 10 seconds and do nothing during the pause. Neurons in the hippocampus and cortex, areas of the brain involved in learning and memory, engage the same patterns of neural activity that occurred during the actual activity. This aids in memory. Microlearning. Break down the content you have to learn. Elaborative rehearsal. Avoid interference by using inquiry-based learning to form associations and thus create cues for your memory. And elaborative interrogation to avoid attention residue or the cognitive switching cost / switching penalty. Cognitive load. Achieve desirable difficulty by seeking clarification. Follow the coherence principle to avoid the redundancy effect and the split attention effect. Partly through visuals. For example, the worked example effect or completion tasks like cloze tests / fill in the blank questions. But consider the guidance fading effect and the expertise reversal effect. Pushing yourself just outside of your comfort zone to facilitate deep processing of what you're learning is known as deep practice. Modality effect. Present the information using 2 different formats. Isolated interacting elements. Effect. Break down and then combine components of what you have to learn. Goal-free effect. Goal-free problems require students to then focus on the information they have and require more problem-solving skills. Imagination effect. Once you've gained some experience, solve problems using your imagination. Transient information effect. Avoid this. It occurs when permanent information, such as written text, is converted into equivalent impermanent information, such as speech, resulting in reduced learning. Variability effect. Learners' exposure to highly variable tasks results in better learning. Newbies should initially be presented with low variability, high guidance learning tasks. Einstellung effect and diffuse mode are related to this concept, although focus mode is also important. Collective working memory effect. Collaborative learning. When people work together in small groups to help each other learn, is an effective instructional approach. The website FocusMate can be used for this. Contextual interference effect. Taking breaks between an activity actually helps us to better learn that activity. That is to say that if you have 30 minutes to practice, you are better off dividing that practice into 3 times 10 blocks with rest in between. Switching from one task to another is more challenging and less boring. That means you pay attention. And attention leads to plasticity. However, multitasking worsens performance. Also, considering the importance of staying hydrated, consider drinking water during your breaks. Self-explanation principle. Trying to explain how new information is related to known information or steps in a problem-solving process. Delayed note-taking. Consider chunking and using mnemonics. The misinterpreted effort hypothesis demonstrated that students would typically avoid strategies that require a little more effort, even though they may increase learning efficiency and bring better results. Common strategies like linear note-taking will bring common results and fast knowledge decay, but the results in retention could be far higher using other strategies based on neuroscientific research. Feynman technique, aka protege effect. Explain what you're learning as if you're teaching someone to figure out where your gaps in knowledge are. Testing effect. Practice tests are even better than self-explanation. Retrograde reasoning. If you get stuck, it may help to explain what you're learning in reverse. Spend about 1/10 of your study time revising old material. Insert brief periods of revision of old material into the study of new material. Spend about 1/4 of your time practicing with a final test format, for example, multiple choice. Spend the remaining 3/4 practicing with recall combined with deep processing techniques. And automate things to reduce decision fatigue. Something else I realized is that it helps to do short tasks right away. For 1/2 of your study time, simulate the environmental conditions of your test, a noisy/quiet environment, similar distractions. For the other 1/2, alternate rooms, places, and conditions as you study. Test yourself with different kinds of practice questions. If possible, try different ways of asking yourself questions to maximize your flexibility. Physically engage with what you're learning. Gestures are robust behaviors that influence communication, learning, and memory. Although there is robust evidence revealing beneficial effects of gesture on learning across ages and across domains, it is not clear what mechanisms underlie these effects. Gestures may change learning via a variety of cognitive processes, including perceptual, attentional, memory, linguistic, and conceptual processes. If you exercise before learning a skill, you will improve and remember what you have learned better. The same applies if you exercise after learning. Physical activity increases the brain's ability to change, which is a prerequisite for remembering. Biking and running are the examples given. Analyses indicate that aerobic and resistance exercise have a rather small effect on cognitive functioning, while mind-body exercise has a moderate positive effect. Chronic exercise was found to have a greater effect than acute exercise, suggesting that regular training over a longer period is more beneficial for promoting cognitive functioning than a single bout. Mind-body exercise showed the greatest potential for slowing age-related cognitive decline. In contrast to aerobic and resistance exercise, which focus on cardiovascular fitness and strength, mind-body exercise combines movement sequences together with breathing control and attention regulation. Walking during foreign language vocabulary, encoding improves subsequent recall compared to encoding during physical rest. Even very light physical activity during encoding is beneficial for subsequent recall. Research shows that physical exercise releases proteins in the brain that can actually help improve your memory and increase your cognitive performance. When you do any type of intense physical activity, it causes blood to flow to the brain. This in turn fires up your neurons and promotes cell growth, particularly in the hippocampus. This means that just 20 minutes of exercise before studying can improve your concentration. Experts have found that there is a connection between being physically healthy and delivering a strong academic performance. This is because low-intensity exercise can give our energy levels a much-needed boost, which is perfect for when you're studying long hours. Studies also prove that exercise boosts creativity and mental energy. Moderately paced walks stimulate the release of a protein called brain-derived neurotrophic factor, or BDNF, that is key to the survival of existing brain neurons and the generation of new ones. Walking increases the flow of oxygen and nutrients to the brain, which can open the gates to enhanced creativity. The brain uses about 3 times as much oxygen for healthy neuron function as muscles do, and is extremely sensitive to decreases in oxygen levels. Studies show that the simple act of getting up from your desk and taking a short walk can help trigger ideas. A Stanford University study found creative output increased 60% when participants were walking, even on a treadmill facing a blank wall. When you walk, increased blood flow to the brain initiates a cocktail of feel-good neurotransmitters. Serotonin, dopamine, endorphins is released. Participants who walked more than 4,000 steps per day had healthier brain tissue in the area responsible for memory, learning, and cognitive function than those who did not. One study found that brain region, called the hippocampus, typically begins to shrink in late adulthood, leading not only to impaired memory, but also an increased risk of dementia. The research revealed that aerobic exercise increases the size of the hippocampus. Walking in nature has been shown to be particularly effective at reducing stress levels. The impact of being outdoors may have to do with optic flow, the perception that objects are moving past us as we walk, which quiets the circuits responsible for stress. Elevated cortisol levels may damage cognition and contribute to Alzheimer's disease.